Alright, hey class, so we're going to do quick and dirty part 2 for our stoichiometry lesson or our stoichiometry unit. This one's going to be about limiting reactants, okay? Now what is a limiting reactant? So a limiting reactant limits how much product is produced or limits how much is actually reacted. Now up until now, we always knew, it was pretty obvious who our limiting reactant was. It was whatever was given. If I gave you 2 moles of hydrogen in excess of oxygen, you pretty much knew that he was your limiting reactant. And so this was the guy that you were going to use as your given. However, things get a little bit more complicated when instead of having an excess of O2, you actually have a limited amount. So instead of it just being 2 moles of H2, you also have 2 moles of O2, or however much. Now one of these is my limiting reactant. One of these limits how much it's produced. We need to figure that out. Now if you think about it, limiting reactant is kind of like hanging a poster on your wall, okay? So let's say that if you have a poster, in order to hang your poster up successfully, you need 4 pieces of tape, okay? Stretch your mind. What if, for some reason, I only have 12 pieces of tape and 4 posters? Now, you can obviously see that 4 is a lot smaller than 12. However, does this mean that my 4 posters is my limiting reactant? Is he going to dictate how many posters I can hang up? Or is it going to be the 12 pieces of tape? Well, how we determine that is by figuring out, well, given what I have individually, how many posters could I potentially hang up? Now, if I need 4 pieces of tape to hang up 1 poster, at most, how many posters can I hang up? Yes, that's right, 3. Alright? Now, without realizing it, you did stoichiometry, okay? You had 12 pieces of tape. You understood that there was a relationship between 4 pieces of tape and 1 hung poster, okay? Now that's not the same poster as this. I'm saying how many posters you actually hung up. In this case, it would be 3. However, based on this guy right here, if I have 4 posters, you would think that I could have 4 hung posters. So which guy is our limiting reactant? Yes, you would get it. The 12 pieces of tape, okay? So this is why our limiting reactant isn't based on how much we have, but how much potential product could be made. And you realize that I figured these 2 numbers out independent of each other, okay? I didn't base it off my 4 hung posters based off of how many pieces of tape I had. I didn't base off my 3 posters off of how many posters I had. I did them independent of each other. So that's how we're going to figure out, but this time with compounds, okay? So, let's going back. We are going to find independently how much product we produce on our 2 givens, okay? So on their own. We're going to find out on their own how much product each reactant makes, okay? So what I want to do is problem 3 from the quiz, okay? Do you remember how in the quiz it said that if it gave me 2 specific amounts, of reactants, and it asked me, well, who's my limiting reactant? Well, just like the posters on the paper, the posters that we hung up, we need to figure out, well, how much product does he make and how much product does he make? One of these is going to produce less product. That guy, he's going to be our limiting reactant, okay? Now, it seems like a lot of steps, but it's really just steps easy as 1, 2, 3, like how we've been doing stoichiometry before, okay? Remember, mass to mole to mole, and mole to mass, okay? So it's just those quick steps. So let's go ahead and do it for Al2O3, okay? Now, what am I starting with? What's my given? Okay? What's my given? Yes, you're right. 25.4 grams. Okay? And what is it that I want to find? Now, because I'm trying to figure out a product, you get the choice. You can either choose Fe3O4 or aluminum. However, whoever you choose for Al2O3, you need to choose for Fe as well. That's the one contingent, okay? If you're going to want to find aluminum based off of aluminum 2 oxide, then your second problem, when you're trying to figure it out from 10.2 grams of Fe, my given, you need to want to find aluminum as well, okay? Because you can't compare apples to oranges. They're too different, okay? If you compare two different amounts of product, your answer's not always going to be correct, okay? So let's go back to here. So, like I said, my given is 25 grams. So let's do that first. So, 25.4 grams of aluminum oxide. Alright, so the first step is what? Very good, mass to mole. So if I'm going to go from mass of Al2O3 to moles, what am I going to use? Very good, the molar mass. Now the molar mass is 101 grams per mole. Okay, so because I want to know moles, the per mole is going to go up here. And the 101.96 grams is going to go down here. Okay, now remember, this is just a translation. I'm not changing compounds yet. So it's going to be 0.25 moles of Al2O3. Notice how it's still the same compound as what I started with. It's not until step 2 that you actually change compounds, okay? Also, that the 1 mole is independent of what my formula is. My formula, my chemical equation, has nothing to do with how many moles it is. Remember, molar mass is just saying if I have 1 mole of something, this is how much I would use up, okay? So, now that we have that, I want to find aluminum. So therefore, what molar ratio am I going to use? That's right, 8 moles of Al for every 4 moles of Al2O3, okay? See how the moles of Al2O3 cancel out? So then I'm going to multiply across and then divide, and that's going to give me 0.5 moles of aluminum. Now remember, aluminum is a product, so that can't possibly be my limiting reactant, okay? It can only be either Al2O3 or Fe. But this is about a comparison, so I can't stop here. I have to keep going. Now I'm going to use my 10.2 grams of Fe and try to figure out how much aluminum I would make, okay? So 10.2 grams of Fe. Again, using molar mass, mine is 55.84 grams per mole. Because I want to figure out moles, 1 mole is going to go on top, 55.84 grams on bottom. Now I want you to go ahead, pause me, and figure out the rest of it by yourself and tell me who is my limiting reactant. If you think you got it, then go ahead and keep playing and see if you got it right, okay? So that's going to come out to 0.18 mole of Fe. Again, I say, did I change compounds? No. Okay? So let's keep going. Because I found out aluminum here, I need to use a molar ratio in order to figure out aluminum here. So, because of that, it's not going to be quite the same. Remember, I'm just focusing on Fe and Al. So it's going to be 8 moles of aluminum for every 9 moles of Fe. Okay? And in this case, I would produce 0.16 moles of Fe. Now remember, aluminum 2 oxide produced 0.5 moles of aluminum. So, sorry, this should be aluminum. So who's my limiting reactant? Very good. it's going to be Fe. Remember, it's not aluminum. Aluminum is a product, okay? It's going to be either aluminum oxide or Fe. In this case, Fe. So make sure that you write on the side or write in the top in a box so that way I can see it. Lr is equal to Fe. Okay? To make sure that every time I can see it clearly, because it's not enough to stop here. Okay? To stop here between these two. That's not enough. I need to know that you know how to interpret it and that you can figure this out. Okay? Also remember to show as much work as possible. I can give you so much more points if you show me work. And also make sure that it's nice and clear and easy to follow. Because if you have it written all over the sides of the wall, there's no way that I can follow you. If I can't follow your thinking, then we're in trouble, okay? Alright, the last thing that I want to talk about real quick is that now that we know that our limiting reactant is Fe, that means that for all my calculations now, my given is going to be the 10.2. I can essentially ignore the 25.4 grams of aluminum oxide. Okay? I can essentially ignore it. So for all my starts, all my givens are going to start at 0.2 grams, and then it just depends on what I want to ask. So in this case, determine the mass of aluminum. My want would be aluminum, but my starting point would be 10.2 grams of Fe. So from now on, anytime you do any calculations with this scenario, this is how it's going to be set up, okay? Alright, I hope that helped. Now remember, practice, 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 and I hope you're going to do just fine on your test, okay?